In this section of Lines of Thought, we have 3 centuries or more of the development of human understanding of gravity and how gravity operates and why gravity operates. This is the first edition of Nicolaus Copernicus' De Revolutionibus. It is revolutionary, in fact, but his reference was to the revolution of the planets about the Sun. It is essential to have this idea to create what we know today about the solar system. We have here Tycho Brahe's De Nova Stella. It was written about a new star, a nova, so a very bright star that exploded in the constellation Cassiopeia in 1572. So we're talking about 30 years after Copernicus's time. Tycho Brahe had his own ideas about the arrangement of the solar system. And the diagram here shows his arrangement, and he wanted to keep the Earth at the centre of the solar system. His pupil, Kepler, Johannes Kepler, who's very famous for planetary laws, immediately rejected the idea and went back to Copernicus's sun-centred solar system. We have here the first edition of Isaac Newton's Principium Mathematica, 1687, which is one of the most important of all publications in the history of science. Importance is greatly enhanced by the fact that it's Isaac Newton's own first edition. It is the great jewel in the crown of the collection. This is Edmund Halley's manuscript notebook. He was famous today, particularly for the comet that's named after him. Halley applied Newton's ideas in gravitation to the orbit of the comet of 1682. He predicted in 1758 that the comet would reappear. Yes, when it did reappear, Halley was vindicated, and a French mathematician suggested that it should be called Halley's Comet. We take the story of gravity into the later 19th and early 20th century from the work of Albert Einstein. He had made predictions of the deflection of starlight, which would be double Newton's. He modified gravitational theory, whereas Newton had explained how the planets moved in the sky. Einstein's theory was giving an actual reason for why gravity operated in space and time. One of the other giants of 20th century research using Albert Einstein's general theory of relativity is Professor Stephen Hawking. He wrote what became A Brief History of Time. It certainly caught the imagination of the public. He was obviously a hugely important mathematical physicist. He sees his own theoretical work very much in terms of a part of the continuum of the ideas and all the great founding fathers of modern science, going back to Copernicus, to Tycho Brahe, Kepler, and then to Newton himself, to Edmund Halley, and the developments of the 19th century, James Clerk Maxwell, Albert Einstein. Well over 200 scientists have deposited their papers in Cambridge University Library, and this has given us a world-class treasure which can be seen in the Lines of Thought exhibition at the library now.
Dear world, yours